This is question 11 of the 2019 HL Math exam for the May examination session. Consider the following equation where m and p and q are real numbers. The equation has three real distinct roots, which can be written as log base 2 of a, log base 2 of b, and log base 2 of c. The equation also has two imaginary roots, one of which is di. So as we know, because of the way imaginary roots work, we know that a negative di will be another one of the roots. And using the sum and product of the roots of polynomial equations formula, we can find the sum of the roots, and this will end up finding this product. So first we can see that the sum is negative a n minus 1, which is the coefficient of this term here, so that's negative 3. And keep in mind that it is negative 3, not just positive 3. And here in the formula, we also have a negative, so it's going to end up just being equal to 3. All the roots are going to add up to 3. So now let's add up the roots. We have log base 2 of a plus log base 2 of b plus log base 2 of c plus di minus di, or well, it would be plus negative di, which just becomes minus di, is equal to 3. And keep in mind the denominator here would be 1 because the coefficient of the first term is 1. So we're just going to, instead of writing 3 over 1, we're just going to write 3. So next we know that these terms will cancel out. Di minus di is obviously going to be 0. So we can get rid of these. And now we know that log base 2 of a plus log base 2 of b plus log base 2 of c is equal to 3. And using the log laws that we can see here, where we have log base a, or log a, sorry, plus log b, we know that this is equal to log of a times b, and this can be applied for this as well. So we can put log base 2 of a b c is equal to 3 by combining all of these logs together, which will give us this. And the intermediate step would be that we have log base 2 ab plus log base 2 c. And again, we use that same logic from earlier here, is equal to 3. So next, that's not exactly what we're looking for in the question. We want to know that ABC is equal to 8. So now using the ways that logarithms works, we know that 2 to the power of 3 will be equal to the inside of the log. So if we write that down, we know that 2 to the power of 3 is equal to ABC. And 2 to the power of 3 is obviously 8. So we know that ABC is equal to 8.